3, 2, 1. Tower cleared.
We got a roll program.
Could not have claimed to know what was in our own solar system until Voyager conducted its tour.
Get ready to be amazed because the brilliant Elon Musk is at it again. Amidst his busy schedule of conquering industries like electric cars and space travel, Musk has made a mind-boggling announcement related to the iconic Voyager spacecraft. As a self-proclaimed proper nerd, Musk's latest revelation has surprised everyone in the scientific community. So what did one of the twin Voyagers uncover this time? And just how long can these space explorers keep up their incredible journey through the unknown? In today's thrilling video, we unveil Elon Musk's stunning reveal of Voyager's latest and most recent discovery in space. Get ready for an interstellar adventure like never before. When Elon Musk was just a lanky 6-year-old, NASA launched the 2 Voyager spacecraft into space. Now as an adult, Musk shares a connection with these iconic spacecrafts. After all, he launches rockets from the same launch site in Florida, Cape Canaveral, where the Voyagers took off from. It's incredible to think that despite being over 50 years old, the Voyagers are still out there in space doing their thing. At the time of their launch, not many could have predicted that the Voyagers would continue their mission for decades. The original plan was for a 4-year mission, but these resilient spacecrafts have surpassed all expectations, continually revealing new insights about the vast universe. What many people don't realize is that the Voyager's launch hinged on a rare celestial alignment. The 4 largest planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, had to align in a unique configuration. The last time this occurred was during Thomas Jefferson's presidency in the early 19th century. This alignment allowed the Voyagers to receive gravitational boosts from each giant planet they passed, like being pulled along by an invisible cord that snapped at the last moment, propelling the probes on their extraordinary journey. Gary Flandreau, a brilliant mind at NASA's Jet Propulsion Laboratory, crunched the numbers and came up with a groundbreaking idea. Using gravity assists to slash the travel time from Earth to Neptune from 30 years to a mere 12. But there was a catch. This rare alignment of planets only happened once every 176 years. Undeterred, NASA sprang into action, realizing they had a once-in-a-lifetime opportunity that couldn't be missed. To take full advantage of this cosmic alignment, NASA decided to build not just 1, but 2 identical spacecraft, the Voyagers. These small, sturdy probes were about the size of an older Volkswagen Beetle, equipped with a computer that had a meager 69 kilobytes of memory, less than a fraction of what a modern smartphone holds. In fact, a car key fob has more memory than these pioneering spacecrafts. Despite their limited technology, the Voyagers were armed with 8-track tape recorders to store all the data collected by their instruments. These recordings would be transmitted back to Earth using a transmitter with the power of a refrigerator light bulb. To compensate for this weak signal, the Voyagers carried massive 12-foot wide dish antennas to send and receive data across the vastness of space. Since their launch in 1977, the Voyagers have made numerous groundbreaking discoveries. Voyager 1 currently holds the record as the most distant artificial object from Earth, billions of miles away in interstellar space. However, it's not an easy feat to stay operational in such a hostile environment. Voyager 1 now braves extreme cold temperatures, pitch-black darkness, and dangerously high radiation levels. Solar power is not an option for the Voyagers, as they are too far from the Sun to receive any meaningful sunlight. Instead, they rely on radioisotope thermoelectric generators, RTGs, for their energy. Each Voyager carries 3 RTGs that use plutonium-238 as a fuel source. As the isotope decays, it produces heat that is converted into electrical energy. Initially, each Voyager generated 470 watts at 30 volts DC, but over time the power output has degraded. Nevertheless, this remains one of the few viable solutions to power the spacecraft for decades, allowing them to continue their mission of exploration in the depths of space. In March 1979, after 546 days of traversing the vast expanse of space, Voyager 1 finally reached Jupiter. Its twin, Voyager 2, had launched just 2 weeks prior and followed a different path, arriving in July of the same year. These extraordinary spacecrafts were designed as stable platforms for their cameras, which used advanced filters to capture stunning full-color images of the planets they encountered. Unlike spinning tops, the Voyager's rotational motion through space was deliberately kept slow, more than 15 times slower than the crawl of a clock's hour hand, to ensure crisp and clear images. This meticulous design decision minimized the risk of blurred pictures that could jeopardize their groundbreaking mission. Voyager 1 began transmitting images of Jupiter while still months away from the gas giant, and the quality and detail of those images were unparalleled. The most astonishing discovery was the colorful appearance of Jupiter's moon Io, which defied all expectations. Prior to the Voyagers, it was assumed that all moons in our solar system would be similar to our own moon, dull and cratered. However, the Voyagers shattered this misconception, revealing a dazzling diversity of moonscapes around Jupiter and Saturn that had never been anticipated. The Voyagers were also equipped with powerful instruments, including the Low-Energy Charged Particle (LECP) detector system. While more than 1 million miles away from Jupiter, the LECP detected unusual signals that left scientists puzzled. Oxygen and sulfur ions were hitting the detector at levels never measured before, having increased by 3 orders of magnitude. At first, the team suspected a malfunction, but upon closer examination, they realized that something extraordinary was indeed happening. Furthermore, the Voyager cameras unlocked a long-standing mystery, whether Jupiter's moon Io was home to active volcanoes. This moon, slightly larger than Earth's moon, was confirmed to be the most volcanically active body in our entire solar system. Surprisingly, Io had 10 times the volcanic activity of our own planet, shattering our previous understanding of volcanic phenomena. The mesmerizing colors of Io and the bizarre ions detected by Voyager's instruments were traced back to elements ejected from the moon's furious volcanoes. The largest of Io's volcanoes, aptly named Pele, spewed plumes reaching 30 times the height of Mount Everest, with its debris scattering across an area the size of France. The Voyager's cameras captured over 33,000 images of Jupiter and its moons, revealing a treasure trove of previously unknown information. For instance, Jupiter had rings, a fact that stunned scientists. Europa, one of Jupiter's 53 named moons, was found to be covered in a cracked icy crust estimated to be over 60 miles thick, adding another layer of intrigue to this enigmatic moon. As the two Voyagers continued their epic journey, they reached Saturn, where Voyager 1 plunged through the planet's majestic rings and flew past Titan, Saturn's largest moon. Voyager 2, on the other hand, set its sights on Uranus and Neptune, making groundbreaking discoveries along the way. It spotted 10 new moons around Uranus and confirmed that Neptune, like Saturn, had its own set of rings, expanding the list of ringed worlds in our solar system. Voyager 2 pressed on, reaching a point 2,980 miles above Neptune 3 years later. Here it measured the fastest wind ever recorded in our solar system, clocking in at a jaw-dropping 1,000 miles per hour. Voyager 2 also confirmed that Neptune's largest moon, Triton, was one of the coldest places in the entire solar system, with surface temperatures plunging to a bone-chilling -235 degrees Celsius. Yet despite these extreme conditions, Triton was found to have ice volcanoes erupting nitrogen gas and powdery particles up to 5 miles high, adding another astonishing revelation to the Voyager's illustrious journey. Voyager 1 is also known for capturing one of the most iconic photos of Earth, has a story that wouldn't be complete without the persistence of renowned astronomer Carl Sagan. When NASA was ready to turn off the cameras on both Voyager probes after capturing images of Neptune and its moons, Sagan insisted that Voyager 1 take one last batch of photos. Despite initial plans to end the mission after Neptune, Sagan's influence led to Voyager 1 aiming its camera back at Earth on Valentine's Day of 1990, capturing 60 final shots, including the legendary pale blue dot. Taken from a distance of 3.8 billion miles, this image remains the most distant portrait of our planet ever taken, with Earth barely visible as a single pixel, veiled by sunlight reflecting off the camera's optics. Even today, the Voyagers are still in contact with the control center, but they recede between 3 and 4 light seconds every day. Scientists connect to them using NASA's Deep Space Network, which comprises 3 tracking complexes strategically located around Earth. Both Voyager probes have now crossed the heliopause, the boundary of our solar system, with Voyager 1 crossing in August 2012 and its twin following suit more than 6 years later. However, the Voyagers, true to their nature of surprising their handlers, have recently thrown NASA for a loop with some mysterious data. Voyager 1 in particular has been sending back signals that don't seem to align with what's expected from its Attitude Articulation and Control System, AACS, the system responsible for controlling the spacecraft's orientation and maneuvers, including pointing its high-gain antenna toward Earth. NASA scientists are scratching their heads, unsure if the data is even legitimate or if it's just randomly generated noise. Despite its age, Voyager 1 has been a workhorse for NASA, performing admirably for the most part. However, the team is keeping a close eye on these puzzling signals, diligently trying to determine if the invalid data is originating from the AACS itself or from another system involved in producing and transmitting telemetry data. In a surprising turn of events, even Elon Musk's SpaceX has offered to lend a helping hand, with potential plans to fix the issue through a software update. The Voyagers are no strangers to problems. In 2017, Voyager 1's primary thrusters began to show their age, but the skilled engineers promptly saved the day by switching to other thrusters that had operated flawlessly during the mission's planetary encounters 37 years earlier. This is just one more example of the amazing design and incredible longevity of the Voyager spacecraft. Meanwhile, Voyager 2 has only 5 instruments left that are still working, with some functions shut down to extend the power source. To conserve energy, NASA turned off the heater for the cosmic ray detector. But Voyager 1's situation is even more dire, with only 4 instruments still operating. The magnetometer and the plasma science instrument will probably be the last 2 instruments NASA turns off. These instruments are nestled in the spacecraft's body, where they still get some warmth from the computer-generated heat. Even with all their instruments turned off, the Voyagers will continue to journey through space. They will remain there long after we are gone and may even reach our closest star, Proxima Centauri, in roughly 16,000 years. So, what do you think of the incredible Voyagers? Share your thoughts in the comments section below.